what's the slope of this line? Now, in order to find it, in order to find the slope, I want you to look back to what you've written down in the past few days about how we find the slope and what the slope actually represents. So take a look at the line, take a look at the values and things that you have written down in your notes, how you can find the slope. What does the slope of a line represent? What's the definition, gentlemen, of the slope? Sarai.
A measure of the steepness of a line.
The measure of the steepness
Of a line.
of a line. And that's represented by a value. Right? The way that line is moving, we can represent that as a value. When we're talking about the slope, we're talking about, is it steep? Is it flat? How is it moving? And who remembers, how have we found the slope of a line? What have we done?
Rise over run.
Rise over run. And what is that? What does that even mean?
The rise is the line.
What about the y?
How much is it going
How much it's going up or down? Okay.
And then the x is the run.
And that means, and what is that?
How much is going up?
How much it's moving from left to right. So when we're talking about this movement, a lot of students say it's how much we're moving for y and how much we're moving side to side for x. Moving from where to where? How are we going to figure out like where I start and where I'm going? From, say it louder, please.
1 point to another.
From one coordinate on our line to another. Is there another way? Actually, there is. We're going to talk about it in a minute, so we're not going to jump to it yet. Looking at that line, can you find the slope? Does anyone have a value that we can? Anyone have ideas? Any of the values you think might be the slope?
Oh, you're right.
2. Okay. Any other values?
2.25.
2.25. Any other values that we might be seeing? Any other values for the slope? Where can we start? If we're going to try to determine the slope for this line, where can we begin?
You can add the one.
What do you mean add the 1? For the slope?
No, like, like the.
Oh, you're talking about the line itself. We're going to address that shift in just a minute.
No, like it doesn't start at the origin.
It doesn't start at the origin. Where is this line?
1, y.
What's the coordinate there?
0.
X is 0,
1.
y is 1. What are the other coordinates on this line?
4, 1, 1,
2,
4.
5.
4, 1? Yeah, 4, 1.
This is X is 2.
Oh wait, 2, 1.
2.
Y is 5.
Wait.
Good.
Is it perfect? 4.
And how about this coordinate?
4 is 9.
X is 4, Y is 9.
9.
Okay. So now using these coordinates, how could I find the slope from one point to the next? Because that's really what we're doing. We're going to look from one coordinate to another. How are we moving? How are we moving?
We are we increasing?
That's a good question. Are we increasing or decreasing?
They said there was a way to tell the difference, but
Well, let's think about this. What kind of line is that? Is that line going up or going down?
I think it's going up.
It is going up. Our line is increasing. It's going up. If our line was going down, it would look like that. So if our line is going up, what must the sign of our slope be?
Positive.
It'll be a positive. Our line is going up, so our slope will be represented by a positive number. Okay. How do I find that number?
Divide by the rise.
Using the form y 1 minus y.
Like,
Okay, so that formula, which we're going to talk about in just a minute, you can find that y2 minus the y1, x2 minus the x1. Ultimately, what is that value helping you to find? Or how are you going from one value to another? The rise over run. Okay, so how can I represent the rise on my line? Like, rise from where?
rise from 0, 1.
Okay, so if I start at this coordinate, how am I getting to the next one?
You go over 2.
What's my rise?
Oh, you go up 4.
And what's my
Oh, the rise.
I noticed that because
Rising 4.
So I'm rising 4. I'm going from a y value of 1 to a y value of 5. So I went from 1 to 5. I increased 4. And then I went from an x value of 0 over to an x value of 2. So my run would be 2. Can I simplify that?
Yeah.
So what's my slope?
2.
Now let's say I didn't see the coordinate D, and I only saw the point A and the point B. I didn't see this one. I didn't see that. Could I represent my slope going from coordinate A to B?
Yeah.
Yeah, how much am I rising here?
4.
8.
I'm rising 8, and how much am I running?
4.
4. And what's my,
2.
it still simplifies to 2 over 1. So, and this is what we talked about last week, using that idea of the triangle. It doesn't matter what point you go from and what point you go to. On a straight line, your slope will always be the same. So here, our slope is 2. So now we're going to find the y-intercept. What do you think of when you see the word
I know this.
y?
Miss, I know it.
What do you think of when you think of the
Can I draw it?
y and intercepts? Explain to me what comes to mind.
Like when you can I draw it? Because I like when I draw it.
You can draw it as somebody else explains it.
Yes.
What do you think
Yes.
of, David? What do you think of when you hear y-intercept? You think of football.
Like
Yeah, a lot of us think of football. And what about football do we think of?
When you cross.
I think
In football, what's an interception?
when somebody else like
when
when somebody else like
side.
when you're like crossing over the y-axis, like
So in math, our y-intercept represents crossing over the y-axis.
I'm not following.
Y intercept. Look,
Where
you
is
cross over. Right?
Yes. Now let's go even more specifically into that. Okay. So Jeremiah is showing when it crosses over. Well, let's narrow.
That would have been fun.
I don't mean to erase, but I am. Let's narrow down specifically because we're gonna pull a little bit of what all of you were saying. You said cross over. Somebody said football. Now explain to me if I'm playing in a game, and it could be soccer or basketball. You can intercept a pass in a lot of sports. But in football, it's specifically called an interception. And if I'm passing a ball to Jordan, what would someone have to do to intercept the pass?
Go in front of her and take her.
You'd have to cross our path, right, in between there. So if you think about this axis, our y-axis, what do you think it means to talk about a y-intercept?
Over the y-axis.
It's where our line crosses the y-axis. So it's the y value
We talked about this last year. I remember.
when a line crosses, and you could write this definition down if you don't have it, the y-axis. And the key here is that it's also represented as a value. So for that line, what is the y-intercept?
1.
1. It's the value 1. It's the y value when a line crosses the y-axis.
Can I get a more hard one? I remember it being hard last year.
You'll see others that are not whole numbers, and there's ways to find the y-axis if it's a decimal or a fraction. And you'll see some examples as we develop further into the topic. So our y-intercept is the y value when a line crosses the y-axis. So now here's what we have. We know our slope was 2, And we know our y-intercept is 1. Our line is crossing the y-axis at 1. How can I write an equation to represent this line? Now it's actually you'll laugh a little because when we did those visual patterns, think back to some of the visual patterns where you came up with the equation to represent the pattern. It's actually the same thing. So as you're thinking about an equation, in order for a coordinate to be on the line, like the x and the y value, it has to make our statement true. And for those of us that are having a hard time developing it, I want you to think about this. What's happening every time we increase our x value by 1? What's happening? Every time my x value increases by 1, what's happening to my y value? It's going up by 2. So what would that look like in an equation?
Y equals 2. What?
Y equals 2x. Now, is that the equation for this line? If that's the equation for this line, what would happen if we substituted in an x value for a coordinate? What would the y value be? For example, these are the coordinates on our line. Do those x and y values work in the equation to my left?
No.
No, why not?
The 5 and 9 don't go by the same.
Well, if my x is 2, and I substitute in a 2, would y be 5?
No, because like since it's not going through the origin, it's not like at a constant rate.
So my line doesn't go through the origin. Is my line still growing at a constant rate?
Yeah.
Still straight. So what should I do to my equation that might help me out a little bit? Does that work?
Yeah.
If I put in x is 0 here, does y equal 1?
Yeah.
Yeah. How about if x is 2? Is y 5?
Yeah.
Yep. And how about if x is 4?
Yeah.
Yep. Y is 9. We're going to talk about where this comes from. The idea
Y
of this
is
equation.
9. That's a funny sentence.
Why can this line not be represented by y equals 2x? Because y equals 2x is 1 off. Right? Something's going on with my line. Let's compare here, these two.
Compare the
Let's compare the slope and the y-intercepts. How are these two? I want you to look at both graphs. Find one similarity and one difference between them. When you find a similarity, give me a thumbs up. When you find a similarity between the two graphs, give me a thumbs up.
How about a difference?
Start with similarity and then we're going to get to the difference. Similarity. Eric, what similarity do you see?
The slope's the same.
The slope is the same. How do we know the slope's the same?
The rise over.
Well, I can actually look at my rise over run. I'm going up 4, over 2, up 4, over 2. And just by looking at the lines, what do you notice? That would indicate that our slopes are probably the same. How do those lines look?
The right over
They're straight lines. And how are they moving?
They're not.
Moving up.
They're moving up. At what rate?
2, 1.
The same rate. So those two lines are what?
similar.
Yeah, they're the same, right? They're moving at the exact same angle. They're increasing the same. They have the same slope. They really do look the exact same.
Yeah.
So what is different? If you see a difference, show me a thumbs up. Difference, thumbs up. Jocelyn, what difference do you see? Different coordinates. Oh, good. We definitely have different coordinates. So this, we have, what's that coordinate?
0, 1.
0,
0, 1.
2,
Oh, never mind.
4. This one is 4, 8. But over here, we have 4, 9.
Yeah, one goes through the origin.
One of them is going through the origin. What did I do to this graph on the left compared to the graph on the right? I just moved it up 1. Right, and that's where that +1 comes from
Fact.
in the equation. It's the same shaped line, but I just moved it up. We already did that, so I'm going to skip over it. So, which one of these graphs is linear?
The second one.
Think about this one before you jump out. Which one of these graphs is linear? Now think about what the word linear means. If you don't have a definition in your head for linear, think about what word it sounds like.
Both of them
Line.
linear.
Line.
So which one is linear?
Both,
Why both?
because they're both straight.
They're both straight lines, which means they both have what kind of rate?
Constant.
Constant. And that's what makes our lines linear. That's why some straight lines. So which one's proportional? Which one?
That
The
one.
right one.
The one on the right. How do you know it's proportional?
It's the
Goes to the origin.
Straight lines through the origin. So as you can see here, all proportional relationships are linear. But not all linear relationships are proportional. This is linear, straight line, but it doesn't go through the origin. So let's take a look at this. You actually saw this last week. I want you to take a look and see, now let's break down what's happening here, because this is a little technical, a little mathy, but this is an option for finding the slope, and there will be plenty of reasons why you would want to use a format like this to find the slope. So here, we have a line that's passing through 0, -2, and 3, 4. This formula you have written down from last week. This symbol here, that little triangular symbol, that's the Greek symbol for the delta, which is change. So that really breaks down to the change in y over the change in x. So what I'd like for you to do is follow what was done here. Take a look at this formula and look at this calculation. And using the graph, I want you to identify where did these numbers come from and why were they put in this formula in that way. Now it is color coded for you to kind of see it and follow it along. But how did we end up with a slope of 2 for this line? Take about a minute. And if you have an idea, I want you to share it and talk it out with the person closest to you or next to you, so that we can come up with a way to kind of break down how to find a slope in another way if I didn't want to just use a point and count, rise over run. Because I may not always be able to do that, and I'll talk about some examples when you may not be able to do that. Okay. Where did they come up with the 4? Where did this -2 come from? Where's the 3 and where's the 0? Okay. So take a look. Try to come up with an answer for where did that come from? And how does this work for us?
Laura, where did this come from? How does this work? Let's do this action. Let's go out.
You want extra time, babe?
Okay. Where did those numbers come from? I know it.
Y minus 1, Y is
Oh, I get it.
Oh, I get it.
Okay, so let's take a look
yeah.
at the calculation down here. So we ended up with a slope of 2, and we need to figure out where. If you're looking at the graph, you could have potentially just counted up 2 over 1, but we want to see where this formula came into play. So if I'm looking down here at the 4 minus -2, where did that come from? Who wants to share where the 4 and the -2 came from?
I got that the 4 is the y and
The
2
4
is
is
the
the y coordinate for this, the y value for that coordinate.
and -2 is y as well.
Good. So that's where our y's came from, and you can see here they labeled them y2 and y1, and they substituted into that formula. By doing the 4 minus the -2, what did they actually find?
And then they subtracting a negative.
Okay, subtracting a negative, so that's where we got the 6, because 4 minus a -2 is 6. But where's the 6 in the graph? Where's that?
Where's that there you got when
The
you
rise.
It's the rise. Yeah, it's actually that calculation, the numerator of that formula, is actually the difference, which is why they subtracted, between the y value here and the y value here. And that rise is 6. So we're rising 6 to go from the y value of -2 all the way up to the y value of 4, you actually moved 6 units. And then how about the denominator, the 3 and the 0? Sarai.
They subtracted 3 minus 0, so that's
They
not
took this x3, good.
x2 minus x1.
Yeah, they took the second x value, and they subtracted the first x value. And again, what's that representing? That's the change here in our x value. We went from an x of 0 to an x of 3. It's the difference between the coordinates, and that's why it's represented with subtraction, because when we are finding the difference of something, we subtract. Okay. So your value here would be 6 over 3, which simplifies to 2. Now you may see a scenario where your coordinates are not whole numbers, decimals, maybe fractions. This formula will work no matter what. If you have to count a rise and a run and you're dealing with coordinates that are decimals or fractions, that could become really challenging. But knowing that you always have this option, this would be a guarantee that you'd be able to find the difference between the y values and the x values of any coordinate. So now we're going to put this all together and we're going to break it down to the equation of a line. Okay. Are you okay? No? If you're doing iReady, just wait a few minutes because I want to go over this last few things. So now we can use this formula, y2 minus y1. We can use that formula to actually derive the equation of a line. We're going to come up with the general equation of a line, and we're going to know where it came from. So now we're going to do a few things here. We're going to use this formula with 2 points. One of them being the origin, the other one being some general point, which we will just call x and y. If I were to use this formula, I have my y2, my x2, I have my x1, my y1. What would fill into this box if I was using this formula? If this is my that's one coordinate and that's another one.
0.
Y minus 0. And then what would be here? X minus 0. What's y minus 0? Y. Good. And what's x minus 0? X. So our slope, which we're calling m, would be y divided by x. So now if I had this, and this is almost like a literal equation, what would I have to do to get x by itself? I'm sorry, to get y by itself?
Multiply by x.
I would have to multiply both sides by x. And look what would happen here. My left side would be m times x.
Mx plus b.
And my right side would just be the y. This is the equation for a linear relationship.
I just said.
Y equals mx plus b. So on half your paper, really big, I'd like for you to write y equals mx plus b.
When you go back to slide, there was no b.
That was because we had, we were assuming it was a proportional relationship, just to go through the equation.
Oh.
And we'll go through some examples. Now, you're going to write this equation really big on a paper, like half a page. And you're going to circle the m. And from the m, you're going to draw an arrow to the word slope. But there's a few ways we can represent our slope. What else do we say when we talk about slope?
Rise over run.
Rise over run is another one that you want to put there. And then the change in y over the change in x.
Do the dash.
Now this works for any proportional or non-proportional relationships. After you identify some key words for your slope, you're going to circle your b value. That is your y-intercept. Okay, that is the value for y when a line crosses the y-axis. So everybody take one quick minute and fill this out.
Do the dash and I go.
Next room. Y equals mx plus b. M represents the slope, which is our rise over run, the change in y over the change in x. And the b value represents your y-intercept. So as you're writing, if I had an equation that looked something like this, what's my slope?
3x.
3. Not 3x, just the 3. And what's my y-intercept?
5.
5. Good. How about
Oh my god.
what's my slope?
1/3.
1/3. And what's my y-intercept?
-6.
-6. Good. Does everyone have this written?
Yeah.
Y equals mx plus b. M is your slope. B is your y-intercept. There will be an anchor chart hanging up with this on it, but I'd really like for you to have it as well in your notes. And whatever you refer to the slope as, change in y over change in x, or the rise over run. We're going to do one more example.
Which group is doing ISG?
Group 5.
I mean, Island.
I read group 5.
Well, maybe she made us do this one that easy.
Okay, so now take a look here. Take a look here. Take a look here. Group 5 never went last week. That's why.
Yeah.
Is it Limish?
I thought we did it because we had. Oh, you did. It's group 1 today.
Oh.
My apologies. My apologies. You know what? Let's just pause it. We won't do it today. We'll keep going with this. It's okay. Only because we were a little delayed in this lesson. I want to make sure we all get
Can we write
this.
that down?
If I have an equation like this, I have a line. How would I write my equation? And I'm gonna write it like.
Oh, I mean, if that's not a bad thing.
Okay. Now let's take a look at the line. Take a look at the line. We want to write our equation in slope-intercept form. So we want to find the value of m and the value for b. Take a look at the line. How could we find m? How could we find b?
Okay.
Think about what you know based on looking at the line. Think about the information we've used to find certain values on a line. Give me a thumbs up if you know the value for either m or b.
Oh.
M or b. And you know what the m represents, and you know what the b represents. Patrick, which one do you know? B. What does B represent? The y-intercept. Where's the y-intercept on this line? At 4. Our line crosses the y-axis at the value of 4, so my B value is 4. Thumbs up if you know how to find the value for M. M represents what?
Slope.
The slope. How can I find the slope of this line? David, what do you think?
3.
3? Why 3?
Because 0 is there, but 0 equals 4, so 3 plus.
How do we find our slope? There's a couple ways we can find our slope using this.
Rise
line.
over run.
Okay, rise over run. So what would our slope be if we use rise over run? 1/3.
Yes.
No.
Because now look, I go from this point. I'm going from a y value of 4 to a y value of 5, so I'm going up 1. And then I'm going from an x value of 0 to an x value of 3. So I'm going over 3. So that would represent my line. Now we can take this and do it in reverse. If I had an equation that looked like this. What would this look like on the graph? How many points do I need to create a line?
2.
2. By looking at this image, by looking at this equation. Do I know any points on my line by looking
0.
just at the equation? Hold on. Think about what those two numbers represent.
Yes.
Do I know any point on the line?
I thought that was 1/3.
I changed. I'm doing a different one.
Oh.
We're making one up. Where? On On the y-axis, -3. Why would that be a point on my line? Aurelie's saying that this is a point on my line. Is she right?
Yeah.
Why?
So that's a y.
Intercept.
Because that's my y-intercept. Cool. So I've used my y-intercept, and it's a -3. Good catch. And now how can I get another point on my line? Now all I've got is my y-intercept, and I do know my slope.
It'll be 1 and 1/2. So it would be like a 1 and a half.
What?
Wait, x would be a half. Wait. Y will be a half and then x would be a 1.
Where?
The top one.
If x is 1, y is 1/2?
Yeah.
Would that work though if I put in an x of 1, would that calculate to 1/2? What do you think?
One of the points could be 2, 1.
2, 1. Okay. Where are you getting 2, 1?
Because the slope for 2, what?
You have a couple options here for finding another point. You can use the slope, which is given, or you can choose any x value and substitute it into the equation. We know the slope. What's the slope here?
1/2.
1/2, which means how would I move?
A 1/2 rate. Wait, 1/2.
For every 1.
For every 1x, I would move
1/2.
up
1/2.
a half a unit.
And then
If this
You would
is
rise
my
and
rise and this is my run, how would I move from the point that I'm currently at?
Up one
up
over
one.
I can go up 1 and over 2. Up 1 and over 2. So my line would look like that. Now this slope, and Zara, I like how you said it. You said for every 1x, I'm going up a half, which is true. For every 1 I'm moving over, I am going up half. But for every 1 whole I go up, I go over 2. That's where that number comes in as well. So if I know the graph, I can identify the y-intercept and the slope by utilizing that rise over run. But if I know the equation, I can create the graph because I'm given my y-intercept and I'm given my slope, so I could show that movement. Now, it's not always going to be as simple. For example, what would the y-intercept be of that equation? What's the difference between this equation and that one? What do you notice that's different?
2y.
Say
Oh,
again?
it's quadrupled. Right? No.
There's 2 y's. and
Yeah,
one
so
y.
here our y value is not alone. So this is not yet in slope-intercept form because I would need to get y by itself.
So you need to do.
So I would have to divide everything by 2.
It'll be y.
We're going to do examples like that in the next few weeks. Okay, but we're starting right now with these types of equations where you're given the equation in slope-intercept form, and there's a few things you'll be able to do. First, you should be able to look at an equation like this and just identify what number represents the slope and what number represents the y-intercept. Then, if I gave you a value like the slope is 6 and the y-intercept is -2, could you write the equation with those two numbers? Could you write, if I said the slope is 6 and the y value is -2, could you write it like this? And then the third thing would be, could you look at a graph like that and identify the equation, knowing the y-intercept and then finding the slope? Those are like the 3 things that we want to be able to do by the end of the week, right? By today, tomorrow, and it really does flow into each other. So here's what we're going to do. First, there's 2 must-do problems. I really think these should take about 6 minutes total, maybe 7. But at the bottom, the learning target for today is like what we've been doing the whole class, that you can write an equation in slope-intercept form. You have 2 options here. One of them is in the green workbook. One of them is in the black textbook. While you do have the choice, I think the black textbook on page 312 is the better option because it starts with just identifying the number for the slope and y-intercept, and then creating the equation if given the number for the slope and the y-intercept. And then the third is, here's a graph, write the equation. It builds on each other really, really well in the textbook. The green workbook is a little bit deeper, assuming that you already kind of understand and can work fluidly with the slope and the y-intercept. So if you don't have a preference, I would jump into the textbook because I feel like those are just great structured, it's a great structured path to working more and more with slope and y-intercept. Okay, I'm gonna stop the recording, but these two questions first. I'm gonna put about 7 minutes up. When you hear the beep, you should be done with those two questions. If you're not, then try to quickly work through so that you can get right to the practice on page 312 in the textbook or 135 in the workbook.